All right, hello. So today, our goal today um, is to find or graph linear equations by finding a table of values. So again, we're going to graph. Last time we graphed using intercepts, finding the x-intercept and then finding the y-intercept. Now we're graphing by finding a table of values. So, or in other words, actually, another way to say a table of values more common to you is a t-chart. So we're going to use a t-chart. Find some values from an equation and graph them. And then we're going to connect that to make a line. So a couple things you have to know first. We have a couple terms here. The first term is linear equation, and this is something that's reviewed, but you got to know that a linear equation is an equation that graphs a line. So we're going to be seeing linear equations today. Second one, this isn't something that you need to have memorized, something that you need to know the word for word, but you need to know the idea of the graph of a linear equation. We know that it graphs a line. We said that. But more specifically, it graphs a line, and lines go on forever. You learned this a number of years back, the difference between a line and a line segment. These are graphs of a line, not a line segment. So it's a continuous line. It extends beyond the endpoints in each direction and represents all the solutions that are between. So every ordered pair on the line satisfies the equation. In other words, if I show you a little graph over here, and this is our line right here, and I'll put this one in yellow. So this is the line on the graph. You have to put arrows on it because really this line goes on forever in those directions. Okay, all of the points on here, all of these, anything on here, even the decimals in between the actual point, the whole number points, will work, are solutions for the equation of this line. All right. And the other two, hopefully you remember domain is the list of the x values. So if we're talking about domain, that's the x values. And then range would be the list of the y values. So domain versus range, x versus y. We usually think of x coming before y. All right. So here's what we're getting into. The goal was to graph using table of values. So here it is. Here are the steps. Very simply put, I have 4 steps for graphing a line using a t-chart. And the first step here, select 3 random values for x. So as we do this, I'm gonna use this example down here, this equation, and we're gonna graph it. So we're gonna find 3 random values for x. And usually I like to keep them small. The smaller they are, usually the easier it is to solve. So we're gonna do -1, 0, and 1. And now 0 is something that you should always use because 0 is usually the easiest one to solve for. Because 0, you plug in 0, it just cancels things out. So always use 0 because that's the easy one. And then a couple smaller ones. So select 3 random values for x. Check, we selected those. Now, number 2. Substitute each x value into the equation. So let's take these x values. Let's start our equation right here. Let's do the first one. We'll substitute them in. So x is -1, so y equals, we're substituting in for x, we're going to do, instead of 3 times x, it's 3 times -1 minus 2. Now, you can simplify this by saying 3 times -1 is -3 minus 2. And remember, -3 minus 2, whoops, -3 minus 2, that's like saying it's -3 degrees outside and it's dropping 2 more. It's not 3 minus 2, it's -3 minus 2, so that's -5. So our y value is -5 when x is -1. Okay, so there's the first one. Remember, we have to do 3, so we picked 0 as our next one. So we'll plug in 0. We have y equals 3 times 0 minus 2. Now this is nice because 3 times 0 is just simply 0. That cancels out and you have y equals -2. All right. I don't know why that keeps happening. -2 goes right there. And the last one we're going to plug in is 1. plug in 1, so we gotta have, and again, you can pick other values. If you want to do 0, 1, 2, or 1, 2, 3, or -2, 0, and 2, you just have to have 3 values for x. So our third one I picked is 1. So then you plug it in for x, y equals 3 times 1 minus 2. And when you simplify that, 3 times 1 is 3, minus 2, and 3 minus 2, hopefully you know by now, is 1. Oh my goodness. So 1 and 1 would be the other point. Now if you wanted, if you look up here, it says pick 3 random values. I'm going to change this to at least 3, because you could do more. If you want to make sure you're doing it right, it's got to be at least 3. So if you want to do another one, you could plug in 2, and you could figure out, plug in 2, 2 times 3 is 6, minus 2 is 4. Or you can probably see the pattern here. They're all going up by 3 on the right side when you go by 1 on the left side. That's interesting too. But, so we substituted each one into the equation to solve for y. We got all our y values. Y equals -5, -1, and 1. And then it says record your solutions as ordered pairs. And we did that already. We put them into our t-chart. We put the solutions as ordered pairs, so our ordered pairs would be -1, 5, 0, -2, 1, 1, and if you wanted to add this one in, 2, 4. So we're done with that one then too. Lastly, you just have to graph them. Graph them and connect them with a straight line. So we're going to graph them. -1, I'll use blue for this one. -1, -5, you go over 1, and then down 1, 2, 3, 4, 5. 0, -2, you don't go over any, you go down 2. Right there. 1, up 1. Alright, right there. And then over 2, up 4, be right there. And even look, it looks like it's going to graph a line. You connect the dots, draw a line that goes straight through them. Probably look a little bit more perfect than mine, but there's your line. You have your 3 points. We did 4, but you could just do 3. And you graph that line. So now we took an equation here and put it into a graph. We also showed it as ordered pairs. We did 3 different things showing the same thing, really. Okay? So that's our goal, is to graph a linear equation by finding a table of values. Okay? So these steps are important. If you can do those, you can graph. Now I'm going to try one more. And we're going to kind of look, we're going to kind of compare the two, graphing with intercepts and graphing with the table of values. So we're going to do both here. I'm going to first do the second method that we just learned today, and then we'll go back and compare it to the other one. So we have our equation 2x plus y equals -2. 2x plus y equals -2. All right, and if you notice, that's in standard form. It's a little bit different than what we had in the last equation. The last equation was technically called slope-intercept form. It was where it was y equals everything else. And when it's y equals everything else, that's a lot easier to solve. So before we do anything, we're going to change it to that. We want to get y, we want to solve for y. So to solve for y, you can subtract 2x from both sides. We're going to get the y by itself. That cancels that out. Then you're left with y, or positive y, equals -2 minus 2x. Okay? And we're going to take that, we're going to use that as our new equation. Now that's not something you have to do. That's just something that I suggest doing, because it is really easy to do. I'm just going to group this here. It is a whole lot easier to use when you're solving for y. So we're going to use that one. Let's pick 3 random values for x. Why don't we pick... We'll use a couple negatives. Let's do -1, -2, and 0. So 0, negative 1, negative 2. You could pick other values. I'm just picking 3 random ones that seem like might work out nicely. So let's first do the first one. Plug in 0 for x. So y equals negative 2 minus 2 times 0. And if you know anything about multiplying by 0, this cancels out. So y equals negative 2. That's all it is. So for when x is 0, y equals negative 2. Second one, let's try negative 1. So y equals negative 2 minus 2 times negative 1. Alright, so let's multiply this across. This is really like a negative 2 times negative 1, so that's a positive. It's going to be plus 2. So equals negative 2 plus, because those negatives cancel out, 2. And negative 2 plus 2 is going to be equal to 0. Those are opposites. So you get 0 when you plug in negative 1. And then lastly, we got negative 2 as our x value. So y equals negative 2 minus 2 times negative 2. And again, those negatives are going to cancel out when you simplify this. So y equals negative 2. Negative 2 times negative 2 is 4. So it's plus 4. Negative 2 plus 4. You're adding 4 to negative 2. You end up getting a positive 2. So that's right there. All right. So we have 3 values. We have 3 ordered pairs if you want to look at it that way. And we can graph. So let's use, well, we'll use a smiley face for this one. How about? So 0, negative 2. You don't go over at all, you go down 2. There's 0, negative 2. Now it's a little bit big, but let's go negative 1, 0, negative 1, and you don't go down at all, 0. And then you go negative 2, 2. It's going to be right there. And if you look, you've got 3 points. You've got 3 points that look like a line, and you connect the dots through them, and you get yourself a line. So again, you took an equation, made a table of values, and then graphed the line. All right? This method will work every time. As long as you're plugging in right and solving right, and as long as you're graphing right, it'll work every time. That's why we practice these things beforehand, so we can do these successfully. Now, I'm going to look at this graph, and I'm going to go back and just refresh your memory on how to do the intercept form using the intercepts. And remember, when you find the intercepts, you take the equation 2x plus y equals negative 2. Find the x-intercept and the y-intercept. And to find the x-intercept, you plug in y, 0 for y. So that would be 2x plus 0 equals negative 2. That would be 2x equals negative 2. Divide both sides by 2. And x equals negative 1. So that means the ordered pair would be negative 1 and 0. Plot that right here, negative 1, 0. That was one of the points we found before, actually. Y-intercept, the x is 0. So you go 2 times 0 plus y equals negative 2. That cancels out. Y equals negative 2. So your point would be 0, negative 2. 0 over negative 2. And the reason we only need 2 points here is because if it's in standard form, we already know it's going to be a line. It's already linear. So we just need 2 points, and we can connect the dots like this. And then we can compare. If you look, they look like the exact same line. Just 2 different methods of finding the exact same, of graphing the exact same line. So with that, you can go ahead and try this one. We have y equals 2x plus 1. You can try finding the intercepts way, and you can try the table of values. especially want you to find using method 2, table of values. So find your table, graph them, and then if you want to pause that and try that. But just a couple things that are different about graphing with intercepts versus graphing with a table of values. You only need 2 points for the intercepts. That would be the intercepts. Because then you know that it's in standard form, you can do that. Here you need at least 3 points. Over here, it works best in standard form. That's R. And we found that out last week. This one, it works best in slope-intercept form, y equals. So in other words, y equals. I mean, other than that, they're similar. You're finding points. You're not finding necessarily the intercepts for finding the table of values, but what you are doing is every time you do that, you're just using an x value, using the random domain. Whereas with the intercepts, you know that the x is 0, so you find the y, and then you know that the y is 0, and you find the x, because those are the intercepts. So they're different. They both they can one. I mean, one is not easier than the other. It just depends on the situation. So for that, I will show you one thing with number 2 here. So the homework here, if you looked, was numbers 1 through 10 evens, and then try 2 of the word problems. But just number 2, it's okay to have fractions in your answers. So like if you're going to do a t-chart and you have your x and your y, and you want to do 0, 1, maybe 3, how about? 0, you're going to plug in 0 here. 0 here is y equals 2/3 times 0 plus 1. This thing cancels out, and it's just y equals 1. So that works out nicely. But if you do y equals, or x equals 1, you do y equals 2/3 times 1 plus 1. Do your multiplication first, equals 2/3, that's just 2/3, plus 1. And that's going to be 1 and 2/3. 1 and 2/3 as a mixed number. Then let's do the third one. Y equals 2 over 3. Since we're multiplying it by a fraction, we'll do 3 over 1 plus 1. That equals 2 times 3 is 6. 3 times 1 is 3 plus 1. Divide that out, you get 2 plus 1, which equals 3. So 2 of them ended up being whole numbers. But when you graph that, I want you to just to know that taking a look at a graph, and now this is just a rough graph. You're going to plot the points 0, 1, 0 over, 1 up, right there. 1 over, 1 and 2/3 up, so 1 over, and then somewhere between 1 and 2 here. So it's about right there. And then 3 over and 3 up. And you look, it does look like it's going to make a line. Okay, it's not perfect, but that's what it should look like. All right, so hopefully you do well with this homework. All right, that's the goal, graphing with a table of values. See you later.